for belt and for belt system, initial pull is the 25 Newton, and the angle of the smaller pull is the 25 degree, and coefficient is this, and the velocity is 6.5 meter per second. Then find out the power transmitted. This is the power. We have to find out this, and this degree we have to convert in radian. And coefficient, we know the coefficient expressed in fully problem in mu, and then the initial pulley we denoted by di and a smaller degree. Okay, here first important thing we have to know in step 1 we have to know at first the initial pulley. What is the initial pulley? Actually, initial pulley is proved that Ti equal to T1 plus T2. What is T1 and what is T2? Initial T1, actually T1, so T1 is the tight side, and T2 is the slack side. This summation of tight side and slack side is 2 times initial pull. We have to know in this problem. A smaller pulley degree and 150 degree. Step 2. This degree have to convert in radian. We know 1 degree equal to pi by 180. Then 150 degree equal to 115 to pi by 80. And another important term is power. Step 3. We know power. What is power? Basically we know work per time. We know what is work. Force into displacement time. We know the unit. If we consider the SI unit, Newton, and displacement unit is the meter, and time unit time second. Here this is the force, velocity, force into velocity. We know that we have to find out the force and the velocity. If we able to find out the force and the velocity, then easily we can find out the velocity. Already has given 6.5, and velocity v equal to 6.5 meter per second. Okay, remember this thing. Here we know the initial we know the initial pull T, initial pull 5 Newton, and then initial pull equal to T1 plus T2 divided by 2. That means T1 plus T2 equal to 5,000. One number equation. And number 2, we know the formula T1 by T2 exponential coefficient theta. We input here coefficient here and theta, that means this term according to gradient, and then easily we'll get the T1 equal to 1.9242 into T2. This T1 will input here in here, then we'll get easily T1 equal to 179.88 Newton, and T2 will get this one T2, and T1 will get 3290.16 Newton. We have got the T1 and T2. That means we can find out the power. This is the title and this is the slack side. Then we'll apply the power, then we'll get the power. What is power? Power equal to, we know, Titan minus T2 into V, that means velocity. Here, if you have any confusion, you can apply the unit. This unit in meter per second. Just you will put this value T1 minus T2 and velocity, and then we'll get the power is the 1.27 kilowatt. That's the answer. Thank you. If you have any confusion, you can write them in the comment section. If you like, you can give me like or any type of comment you can do in comment section.